Hello.
Good evening, sir.
Yeah. Good evening. Can you hear me?
Yes, I can hear you.
Okay. Which class are you in right now?
10th.
10th. And you are in Fiji.
Yes, sir.
So how's it going so far? Your course in Fiji and all.
It's going fine.
So tell me what all you have you learned in this year uh, for physics, for example, physics and maths.
Ray optics, number systems,
Hmm.
quadratic equations,
Hmm.
and trigonometry.
Hmm. Number
Um,
systems, quadratic, trigonometry,
yeah,
and
and I'm forgetting the other chapter names. Wait.
have you learned anything in calculus?
Differentiation.
Okay. Differentiation you have learned.
Yes, sir.
Okay. Do you know what limits and all are limits, differences? No. Limits you
No,
don't know.
yeah, I don't know what limits.
And anything in integration? No.
I learned a bit of without limits integration.
Mm-hmm. Okay.
Just that much.
And in physics, what all have they done?
Ray optics.
Ray optics. Other
Yes,
than
sir.
that, mechanics, anything?
I did mechanics last year. Mechanics is not in 10th grade syllabus.
But they are preparing you not for 10th grade, no? They are preparing you for JE, right?
Yeah, but the thing is that
Hmm.
they teach 10th grade stuff, but at an advanced level. They don't teach
Hmm.
grade further.
11.
They, yeah, they don't do that. They do that in workshops, but not solely in the class.
Okay. So right now you don't know mechanics much of it, right?
Yeah, not much of it, but I don't know.
Newton's laws and all you know, right? Newton's laws of motion and all.
Yeah, I know that much.
Okay. Have you got the book, HCV book? Have you got it?
Yes, I have it.
So for preparing for this exam, you need to use HCV, okay? And you
Okay.
need to use volume 1 and volume 2, both.
Yeah.
So this exam basically, at least NSEP, is more a test of how much of the syllabus you know. Okay. How much
Okay.
of the syllabus is do you know? And it's not a test of how deep your knowledge is or how much you have problem solving skills. Okay. So the questions in the exam are not very difficult. It's just that they will cover the whole syllabus. Do you understand what I'm saying?
Yes, sir.
So difficulty is that you need to be able to know a lot of physics to be able to do well in the exam. Correct?
Yeah.
So the best way to learn it from HCV book. And what we will be doing is we'll go through the chapters theory in a planned way, and we'll try to do HCV questions, and we'll also look at NSEP PYQs. So whenever we discuss a particular chapter, we'll do HCV plus your PYQs. Okay.
Okay.
So that is the rough plan, HCV plus PYQs. And we need to be a little fast about it. We don't have so much time to go into too much depth. Like we are not going to do JE advanced level here right now.
Yeah.
You understand what I mean?
Yes, sir.
So in all the chapters, HCV is a good level and HCV is enough level to clear this exam. Okay.
Okay.
The questions in the book in HCV are good enough. And when we do the PYQs, you will understand that if you are okay with HCV, then you will be able to solve the PYQs. Okay. So
Okay.
that is what my experience tells me. The most important thing here is, can we cover as much of the syllabus as possible? That's the main thing. Okay.
Yeah.
So that is what we have to try to do. We have 4 months roughly, right?
Yes.
If in 4 months we can cover 70 to 80% of the syllabus, then you will do well in the exam. Maybe a little bit will be left, but if we can do this much also, it will be good enough to clear the exam. Okay. So
Okay.
that means roughly 70 to 80% of 11th and 12th physics will be completed. So that will be also a big advantage for you when you go to 11th, when you're preparing for JEE and all, right?
Yeah.
So your goal is eventually JEE, right?
Yes, my eventual goal is J.
Right. So then if you study properly, study hard for the next 4 months, then a lot of your physics syllabus will be over. So which will be a huge benefit for you. Okay. But one thing that we need to know is, like, before we do any physics, no, we have to do a little bit of vectors and we need to do a little bit of calculus.
Okay.
Do you know anything about vectors?
Yes, I studied vectors last year.
So you know how to add and subtract vectors and all?
Yeah, but I have forgotten all of the formulas. I did no revision.
Okay. There is no formula really. It's not very, it is not memory based. Okay. If you understand it, you cannot forget it. So what we'll do is we'll discuss this and we'll also discuss calculus, because anytime you have to do any serious physics, you need calculus. Okay.
Yeah.
So for calculus, I would say there is a book which you can download, Thomas and Finney. Thomas and Finney. It's called Calculus and Analytic Geometry. This is the book. If you cannot find the book online, I will share it with you. Okay. So
Okay.
this book we need to cover, or you need to cover in the next 4 months, you need to cover at least the first 6 chapters till chapter 6 roughly. By covering, I mean you need to understand the concepts in these 6 chapters. Okay. And
Okay.
the exercises in the book are not very hard. So you can try it and you will also be able to solve it. It is very well explained. Everything is very well explained here. Okay. But
Okay.
it is important that you do it. So this has to be done parallel to our physics prep, parallel to the physics prep. Calculus being strong is super important. Anyway, in 11th and 12th, it will be important. And right now, also to do physics properly, you need to understand calculus. Okay. So after the class, you need to find this book. If you can't find it, you message me, I will send it to you. Okay.
Okay, sir.
Actually, I will send it to you. You can start reading this as soon as possible. Okay.
Okay, sir.
Today's class, what we will be discussing is basics of calculus only. Like today's class and probably next class, maybe the first week we'll spend on calculus, because we have to know our differentiation and integration basics. Otherwise, you can't do anything. Okay.
Yeah.
So if it is done earlier, it's fine. We will move to the physics part. For physics, what you need to do is read up on the homework is HCV Volume 1, Chapter 2, and Chapter 2. Yeah, this week's homework is Chapter 2. And Chapter 2 is what? It's called Physics and Mathematics. Okay. So Physics
Yeah.
and Mathematics, that chapter, it covers everything that we need. Vectors, calculus, everything. Okay. So we have to make sure that we are solid here. Otherwise, it will be difficult to proceed. Okay.
Yes,
So
sir.
technically, our real physics will start next week. That will be chapter 3, kinematics. So if you have time, you can go ahead, but make sure that you cover chapter 2 in this week. Okay.
Okay, sir.
Fine. So right now I'll start talking about calculus. Do you have any questions right now at this stage about the exam, about anything, any concerns?
No, sir.
So you know what you have to do, right?
Yes, sir.
Chapter 2 from HCV and also Thomas and Finney from the beginning. Thomas and Finney from chapter 1 onwards.
Okay.
Actually, there is a chapter 0 in Thomas and Finney, so chapter 0 onwards. Okay. And
Okay.
whatever problems you have, we can discuss that also. This is the work that will have to be done in parallel. You don't have to rush here. You have to do it properly. Okay.
Okay.
In Thomas and Finney, there is no rush. We are not going to write an exam about Thomas and Finney's calculus, right? So
Yeah.
you have to think about it as कि next 4 months में I have to learn calculus, right?
Okay.
So that is the target. As much as possible, you have to do from this book. But for this particular week, chapter 2 HCV, that is the work. Okay.
Okay.
And when I say you have to do chapter 2 HCV, what do you have to do there? Anytime, any chapter for HCV, when we are discussing, you have to read the text very carefully. Okay.
Yeah.
Reading the text is first. Read the text. Don't skip the text. Don't skim over it. Don't just read the formulas. Do you understand what I'm saying?
Yes, sir.
बहुत लोग ऐसे पढ़ते हैं, ऊपर ऊपर से पढ़ते हैं. वैसा नहीं पढ़ना है. ठीक है.
Okay.
बस फॉर्मूलाज देख लिए, इक्वेशंस देख लिए और बाकी मैनेज कर रहे हैं. ऐसे नहीं करना है. ठीक है.
हाँ.
एकदम line by line you have to read it. Line by line. And you have to underline it. If there is a problem, if something you don't understand, you have to mark it in the book so that you can ask me in the class. Okay.
Okay.
So read the text. That is the first step in any chapter. And then it is worked out examples. There are worked out examples at the end of the chapter. And finally, there is exercise. So there is no mysterious or there is no great way to study. This is the standard way to study anything. Okay. And
Yeah.
and that is the way you have to follow for HCV. If you do it sincerely, everything in physics will be sorted. Okay.
Okay, sir.
Fine. Now we'll talk about calculus. So the first concept here is functions. Do you know what a function is?
Yeah.
What is it?
A function is it's an polynomial from in which if we plug the value of x, it would give us fx.
So close, but fx doesn't have to be a polynomial, right? Doesn't have to be a polynomial. Polynomial कैसा होता है? Polynomial is usually something like ax cube plus bx square, something like this, right?
Yeah.
This is a typical polynomial. But a function doesn't have to be polynomial. Function can be anything. It can be f of x is equal to sine square x plus cos x, right?
Yeah.
This is a trigonometric function. It could also be f of x is e power x. F of x is log of root of x. It could be anything, right?
Yes,
So
sir.
it doesn't have to be a polynomial. A function is basically a relationship between two variables, right?
Yeah.
Where you have a independent variable x, which can be the input or independent variable, right?
Yeah.
And that independent variable is being supplied to a machine. This machine does something and it creates the y, which was f of x. Basically, the machine is doing some operation on the x, right?
Yeah.
And it is giving the output y, and the y is called the output or the dependent variable, right?
Yes.
Why is it called dependent variable? Because it is dependent on the value of x, right?
Yes, sir.
So think of the function as this machine that performs this task. It takes input and gives out output, right?
Yeah.
Okay. Now we need to, that is a way to understand what functions are. But what we need to do is make it mathematical and precise, like how to express it mathematically. So what we'll do is we'll take two sets. This is set A and this is set B. And we'll define a function between set A to B. Okay.
Okay.
And this is the way to write it. When I write this thing, it means f is a function from A to B. Right? Okay.
Okay.
And you know what sets are, right? Sets will have some elements and all, right?
Yeah, I know.
So let's say these sets have some elements, like let's say A, B, C, A, B, C, D, E could be any real numbers and all, right?
Yeah.
Let's say this side or something like this, right? Now, what is the function doing? It is showing you a relationship between elements of set A and elements of set B, right?
Yeah.
So you will say A is connected to, let's say, 1, and B is connected to 4, and C is connected to 3, and D is connected to 6, and E is connected to also 6, right?
Yeah.
So now when you see something like this, a diagram like this, it tells us that the input is in this set, the set A, and the output is in the other set, the set B, right?
So this means that f of A is 1 and f of B is 4,
Right.
like that.
Yeah. This means this f of B is 4, f of C is 3, and so on. Right? And
Yeah.
this set is known as the domain. This is just a name given to the set of all inputs. And this
Okay.
set is called codomain. Okay. Codomain
Okay.
is basically set of possible outputs. Okay.
Okay.
Right. So this is the domain and codomain, and there is a relationship between elements of the domain and elements in the codomain. And that relationship is being described by the function. Right?
Yeah.
Okay. So that is the first thing to understand. Now there are two conditions here that you need to know about. Two conditions when the relationship can be called a function. Okay. So first condition is all elements of domain must have some output. Must have some output. Do you understand what this means, this condition?
Yeah, there should be a function from all elements of A to B.
There should be an output for every element in set A, right?
Yeah.
ऐसा नहीं होना चाहिए कि यहाँ पे एक F है and it is not connected to anything.
Okay.
Because that means that F has no output, right?
Yeah.
So it is going against our first rule, right?
Yes.
It is like a bad machine where when you input F, nothing happens, right? Nothing.
Yeah.
So that is not going to be a good machine.
Yeah.
Because then when you input something, if nothing is coming out, then you don't know what to do. And that is not a function, right?
Okay.
So we have to not have situations like that. So I will remove this F, right?
Yeah.
The second rule is very important. It says a single input can only have one output. Only one output. So by that, what I mean is, I should not write a single. Any input can have only one output. I'll write. Okay. So by that, what I mean is, ऐसा नहीं होना चाहिए कि D is also connected to 2 and also connected to 6.
Okay.
Do you understand? If I had made an arrow from D, 1 to 2 and one of them to 6, right?
Yeah.
That means f of D could be 2 also and could be 6 also, right?
Yeah.
That is not allowed because there are multiple possible outputs for the same input, right?
Yes.
That is not allowed. The reason for that is simple. You don't want to work with a machine where you don't know what the output is going to be, right?
Yeah.
If it is going to be 2 on Tuesday and 6 on Wednesday, it is not a good machine.
Yeah.
When you give the same input, you should be guaranteeing that the output will be same, not multiple choice, right?
Yeah.
So that is a condition that should never happen in a function. So here, that's why I have rubbed off that arrow, right?
Yeah.
Notice that this doesn't mean that all the inputs should have different outputs, right? For
Yeah.
example, you can see that D and E are both going to 6, right?
Yeah.
That is totally fine. That's allowed. Because
Okay.
there could be multiple inputs which give the same answer. Doesn't mean that it's not a function, right?
Yeah.
But what should not happen is one single input cannot give multiple answers, right?
Okay.
So if you think about it in terms of a graph, the same set diagram that I had drawn, right? It can be represented in a 2D plane also, in the XY plane also. For example, if A1, or let's put some numbers here. Let's say it is 2, 4, 3, 9, 6, 36, right?
Yeah.
You can see clearly that this function is y is equal to x squared, right?
Yes.
So we can represent them on a graph by thinking of this diagram. This diagram is technically a set of ordered pairs like this. What do I mean by that? What I'm saying is this diagram means there is a 2, 4 pair, there is a 3, 9 pair, and a 6, 36 pair, right?
Yeah.
Here the first element of each pair is the x input and the second element is the output, right?
Yeah. So 2 will be the x coordinate and 4 will be.
So you can mark it on the xy plane. 2, 4 is a point on the function. 3, 9 is going to be a point on the function, and so on, right?
Yeah.
And if you mark enough points, you can even join them with a curve, right?
Yeah.
If you have enough data, enough points here, then you can join them with a smooth curve, and that will be the graph of the function, right?
Yeah.
Are you understanding what I'm saying so far?
Yes, sir.
So this graph of the function is important to understand here, that how to decide if something is a function or not. For example, I can draw a graph like this. This is the sideways parabola. This is not a function. Why is it not a function? Because if I take a vertical line like this, it is cutting the graph at 2 points, right?
Okay.
Why is that bad? If it cuts the graph at 2 points, that means, think about it, it's a vertical line. So the x is same, no? Everywhere.
Yeah, it means the same x coordinate has two y coordinates,
Right.
which.
Which violates our second condition, right?
Yeah.
That is violating our second rule for being a function, correct? So
Yes.
therefore, there is something called the vertical line test. Anytime you see a graph, you can draw vertical lines through it everywhere. If the vertical line cuts the graph 2 times, then that means it's not a graph of a function, right?
Okay.
For example, a circle will not be a function, right?
Yeah.
However, if you just draw the semicircle, that is a function.
Yes.
Is it clear what is this vertical line test?
Yes, sir.
Okay, so functions, basically we have sort of understood. One more thing to notice here is I defined two sets, domain and codomain, right?
Yes.
Domain and codomain. And I will give you an example here. Let's say the function is y is equal to x squared, right?
Yeah.
And these two sets are set of all real numbers. So all negative, positive, 0, everything is there, right? Here also. Right?
Yeah.
I'm not putting any more points. I'm just showing you something. Okay. So the function is y is equal to x squared. So you can easily make the connections, right? -1 will go to 1. 1 will also go to 1, right?
Yeah.
2 will go to 4, minus 3 will go to 9, and 0 will go to 0, right?
Yeah.
So this is the rough diagram that we have, correct?
Yes, sir.
Now think about it. There was one rule that said all elements of this domain set should have output, right?
Yeah.
That rule is definitely being followed, right?
Yeah.
There can any real number that you can think of will have an output here, no? Another real number somewhere here, right?
Yeah.
I have not put all of them because they are infinite, but I am just telling you that that is going to be the case, right?
Yeah.
Second rule is also followed because notice that every single particular element has only one output. It cannot be multiple outputs, right?
Yeah.
Minus 1 has an output which is plus 1 always. It cannot be anything else, right?
Yeah.
Similarly, this also has a single output, right?
Yeah.
Okay, so both the rules are being followed. So this is a function, correct?
Yeah.
But notice one thing. There are points in the codomain set which are not connected to anything in this set, right?
Yeah.
Like -9, -1, right?
Yeah.
Because we know that no square will be negative, correct?
Yeah.
No square can be negative, no?
Yeah. No square can be.
So therefore, you cannot connect any number in this set to -1 or -9 because it cannot be the square of something, right?
Yes.
So what we are getting is in the codomain was set of possible outputs. Possible outputs, but there are elements like -9 and -1 which are not the actual outputs, right?
Yeah.
So the actual outputs, set of actual outputs of the particular function that you are talking about is called range. And in this case, range will be all positive numbers, right?
Yeah.
Here in this set, you can see that the range is 1, 4, 9, 0, right?
Yeah.
But the codomain was the full set. No, codomain also had -1 and -9, right?
Yeah.
So it is okay, that is allowed. You can have elements that are left over in the second set, in the codomain, which have no connection to the domain. Okay?
Yeah.
But the reverse was not true. You cannot have elements here which have no connection here, right?
Yeah.
Do you understand what right now what I'm saying?
Yes, sir.
So basically what I'm saying is range is always a subset of the codomain, right?
Yeah.
Because range will be a small part of the codomain. Sometimes it could be that range is equal to codomain also. That is also possible, right?
Yeah.
But it can never be that range is bigger than the codomain. Range will also always be a part of the codomain, right?
Yes.
So far what we have done is we have understood what a function is. We have understood the terms domain, range, and codomain, right?
Yeah.
So set of actual outputs is range, possible outputs is codomain, right?
Yeah.
Okay. Then we come to uh, basically functions we have understood. Then we have to discuss what is limits. Limits. So limits is simple to understand, but it's a very important concept. It's the idea that let's draw a graph, for example, y is equal to x squared, right?
Yeah.
This is the graph of the function y is equal to x squared, right? Now,
Yes.
if you are coming near 1, right? This is the point x is equal to 1. You will realize that the function value here is also y is also 1, right?
Yeah.
So the idea of limit is as you come closer and closer to 1 from both sides, By that I mean your x values can become 0.9, then after that 0.99, and then even closer 0.999 and so on, right? You can come closer and closer to 1 from the lower side, right? From the left side, correct?
Yes.
Or you could also come closer to 1 from the right side. For example, you could have 1.1 and then 1.01 and then 1.001, right?
Yeah.
From both sides, you are approaching the point x is equal to 1. And what we want to say is, what is the value of the function f of x? What is it approaching?
1.
In this case, it approaches 1, right? Correct? So
Yes.
as you come closer and closer to 1, the function values also approach a particular y value, right?
Yeah.
When you are below 1, the y values are below 1. When you are above 1, the y values are above 1, and both the times they are tending towards a particular value, right?
Yeah.
So basically, when we say limit x tends to a, f of x equals L, this is the standard notation, okay? What this means, how to read it first of all. How to read it? You have to say limit as x tends to a of f of x is equal to L. Do you understand what I'm saying right now?
Sir, so in this case, L is 1
In this case, L is 1.
and A is 1 as well.
A is 1 also. In this case, it is like this. Limit x tends to 1 of x square is 1. Because
Okay.
f of x is x square, right here.
Yeah.
So basically what we are saying is, as x approaches 1, what is the function value going to approach? Right?
Yeah.
And from both sides, we are approaching the same thing, right?
Yeah.
There could be more complicated situations. For example, let's say we have a graph like this and like this. This function, I can show you the function is written like this. It is x square if x is less than equal to 0, and it is x plus 1 if x is greater than 0.
Okay.
Do you understand what I'm saying?
Yeah.
On the left side of 0, the graph is the same graph as y is equal to x square, right?
Yeah.
But on the other side, it's a straight line graph of y is equal to x plus 1, right? Correct?
Yes, sir.
This is also a function. But now, if you think about limit of x tends to 0 f of x here, right?
Yeah.
Correct. So now there will be a problem, because if you approach the 0 point from the left, the function is tending towards what?
0.
0. But if you approach the 0 from the right, the function is actually tending towards what?
1.
1. So from both the sides, the left hand, this is called left hand limit, is not equal to right hand limit. Correct?
Yeah.
When you approach from the left side, the y value is tending to 0. But when you approach from the right side, the limit is tending to 1, right?
Yeah.
So in this case, we will say limit of x tends to 0 f of x does not exist. We say that it does not exist because the two tendencies are not matching, right?
Yeah.
As you approach 0, from one side it is something else, from other side it is something else, right?
Sir, so if the function would have been y equals curly bracket x square comma if x less than 0 and x if x greater than 0,
Then
then
we
this
would
would
say,
have been
then there is no problem. Both sides it is approaching 0, right?
yeah.
Then the graph would have been like this, right?
Yes. Yes.
And then we would say limit in that case would have been 0.
Then this would have been a function.
No, function to ऐसे भी है. Then limit exists.
So if limit doesn't exist, then the function, then the given graph is not a function of a graph.
No.
Sorry.
This देखो, given graph is anyway already a function. There is no issue. Vertical line test में कोई problem आ रहा है?
नहीं.
The given graph is already a function. It's the what we are not discussing whether it is a function or not. Okay. What we are discussing is whether limit of the function at this point exists or not.
Oh, okay, got it.
We have moved to the next topic. Okay.
Yeah.
We are discussing limits right now. So function तो है ही वो, दोनों केस में function है, ठीक है?
Yeah.
But in one case, the limit does not exist as x tends to 0 for that function, right?
Yeah.
And in the other case, limit exists as x tends to 0, and that limit would have been 0.
Okay.
So basically, if both sides LHN and RHL are equal, then whatever is that equal value is your limit.
Okay.
Are you understanding more or less?
Yes, sir.
Okay. What you need to do is chapter 0, Thomas and Finney. Okay. And this
Yes.
limit concept is in chapter 1, limits. And limits is super important concept. So you need to work on it a little bit. It will take 1 or 2 days to do, but you have to do it properly. Okay. Because
Okay.
actually you will realize that everything that you do later, derivative, integral, all of it is based on limits only. Okay.
Yeah.
So chapter 0 and chapter 1, start working on that. I will send you the document, the PDF soon. And for now, just focus on the calculus part this week. Okay.
Okay, sir.
Once we finish, we will be doing the calculus part in a very short way. We will not be going too much into detail, but we will have to know everything, right? So
Okay.
our target is to know enough calculus to do physics. Okay.
Okay.
Because obviously, otherwise, calculus will take several months to do properly, right?
Yeah.
So we are not going to spend that much time, but we still have to have our concepts sorted. So we are not going to take any shortcuts also. Okay.
Yeah.
So just focus on this chapter 0, chapter 1 limits, and see if you are understanding. If you don't understand something, make sure that you mark it or write down in your notebook or something so that we can discuss it later. Okay.
Okay, sir.
For now, this is enough. I think too much will be, then you'll mix up stuff. So just go through the text, and Wednesday's class we'll be discussing limits further and maybe moving on to derivatives. Okay.
Okay, sir.
So by Wednesday's class, I expect you to go through the document that I sent, the PDF, and see what you can understand. If you're facing some issues, find out those issues. Okay.
Okay.
Fine. That's all for now. I'll continue on Wednesday then.
Okay, sir. Thank you, sir.
Okay. Bye.